Dear students, in this video I explain transfer function of the first order system. What is the necessity of this transfer function? Why we identify or why we calculate the transfer function of the first order system? So because if we want to know the order of a system, we have two methods. First one is differential equation method. Second method is transfer function method. If you know the differential equation of a particular control system, then we can find out the order. Otherwise, if you know the transfer function of a particular system, then we can find out then we can know the order of the system. So in this way, we want to find out the transfer function for the first order and second order systems. Initially, we find out the transfer function of the first order system. So consider the first order system. Let us consider the first order unit feedback system. Here I mentioned unit feedback. Unit feedback means the feedback path consists of 1. That means there is no block in feedback connection. Why I take this condition means it is very easy to calculate the order of a system or calculate the transfer function of a system. That's why in generally we are taken unit feedback systems. Consider the one first order system like this. In this system, R of S is the input, C of S is the output, 1 by Ts is nothing but forward path transfer function, E of S is nothing but error signal which is developed by this summing point. And feedback, this is the feedback connection. So this is the feedback connection. In this feedback connection there is no block, that's why it is a unit feedback, right? So this is the one first order system. Now I want to find out the transfer function of this first order system. So already we know this is a simple form or canonical form. How can we calculate the transfer function of a simple form or canonical form? The formula is transfer function is equal to output by input. That is nothing but C of S by R of S. Output is C of S, input is R of S. Therefore, C of S by R of S is equal to forward path transfer function divided by. So this is the forward path transfer function divided by plus or minus. So when we are using plus, when we are using minus, if feedback is positive, we can use negative sign. If feedback is negative, we can use positive sign. Here the feedback is negative. Why? Here the negative symbol is there, so that this feedback is negative feedback, so that this is the negative feedback system. Hence, the formula is C of S by R of S is equal to forward path transfer function divided by 1 plus forward path transfer function into feedback path transfer function. In this diagram, forward path transfer function is 1 by 1 plus Ts, 1 by Ts, and feedback path transfer function is unit. Unity means 1. Therefore, by applying these two parameters, we can calculate the transfer function of a first order system. Therefore, the transfer function of the first order system is 1 by 1 plus Ts. So, this is the first order system transfer function. C of S by R of S is equal to 1 by 1 plus Ts, otherwise 1 by Ts plus 1. So, this is the first order system transfer function. Now, we can find out different responses for the first order system. That means different input signals are applied to the first order systems. So what are the output parameters we have? So what are the output parameters changes in while we are applying different input signals? So first one is first order system response when the input is unit step signal. So order is first order and input is unit step. That means I am applying the unit step input for the first order system. So what is the output response I want to find out? So for this, consider the first order system transfer function initially. So the closed loop transfer function of the first order system C of S by R of S is equal to, just now we calculated, that is 1 by 1 plus Ts. So this is the transfer function of a first order system. Now I want to apply the input as unit step signal. Already I given a formulas in S domain and time domain for the unit step, unit ramp, all these standard signals. So now the input is unit step. If the input is unit step, then R of T formula is 1 and R of S formula is 1 by S. For the unit step input, R of t is equal to 1 from the table. So we can easily identify it. And R of s is equal to 1 by s. Now I want to find out the time response of this first order system. So how can you find out the time response? Time response in the sense C of t. Finally, we want to calculate the C of t. For this R of t is transferred this side. Therefore, C of s is equal to R of s into 1 by 1 plus Ts. Now we want to calculate C of t. How can we calculate from C of s? By applying the inverse Laplace transform. So this is the total procedure for find out the time response of any system in the control system engineering. So now we want to respond. So the response in S domain C of s is equal to R of s into 1 by 1 plus Ts. Because the transfer function C of s by R of s is equal to 1 by 1 plus Ts. So that from this transfer function C of s is equal to R of s into 1 by 1 plus Ts. Now R of s value is 1 by s for the unit step input. So apply or substitute R of s is equal to 1 by s in this equation. Therefore, C of s is equal to R of s means 1 by s into 1 by 1 plus Ts. This is C of s value. Therefore, therefore C of s is equal to 1 by so s into st into 1 by t plus s. So st we have taken the common as st. Now, so again we want to transfer this t in the numerator, then 1 by t divided by s into s plus 1 by t. So now this is standard form, that means 1 by s into s plus a like this. So now we would like to apply the partial fractions for this what you call equation, then we can easily find out the inverse Laplace transforms. So apply the partial fractions. So the equation is C of s is equal to 1 by t by s into s plus 1 by t. So apply the partial fractions. Already I given a formulas for first order, case 1, case 2 and case 3. So this is the simple case. So this is the case 1 partial fractions. Therefore, a by s plus b by s plus 1. So by cross multiplying and apply and find out the values of a and b. So a is obtained by multiplying c of s by s and let s is equal to 0. So this is the procedure for find out capital A value. Therefore, a is equal to c of s into s, that is equal to 1 by t by s into s plus 1 by t into s. So therefore s cancel. Therefore 1 by t by s plus 1 by t and substitute s is equal to 0. Therefore 1 by t by 1 by t, that is equal to 1. The a value is 1. And again find out the b value. So b value is obtained by multiplying c of s by s plus 1 by t and letting s is equal to minus 1 by t, or substituting s is equal to minus 1 by t. Therefore, b is equal to c of s into s plus 1 by t, that is equal to c of s means 1 by t by s into s plus 1 by t into s plus 1 by t. S plus 1 by t, s plus 1 by t cancel. Therefore, 1 by t by s. Substitute s is equal to minus 1 by t. Therefore, 1 by t, 1 by t cancel. Therefore, minus 1 is the answer. So, finally, we know or we calculated a value is 1 and b value is minus 1. So, now I want to apply a and b values in general formula. Therefore, C of s is equal to a value 1, so that 1 by s, and b value is minus 1, so that minus 1 by s plus 1 by t. So, therefore, now we want to apply the inverse Laplace transform for calculating C of t. Finally, we want the time response. Time response is nothing but C of t. Therefore, C of t is equal to apply the inverse Laplace transform. Inverse Laplace transform of C of s, that is equal to inverse Laplace transform of 1 by s minus 1 by s plus a. Already we know inverse Laplace transform of 1 by s is nothing but 1. 1 by s plus a is nothing but e power minus at. Substitute the formula. Therefore, 1 minus e power minus a value is 1 by t. Therefore, 1 minus e power minus small t by capital T. So, this is the time response of the first order system when the input is unit step signal. And what is this output response? So, what is the output what we call signal? So, input is unit step. What is the output signal? For calculating this one, we can apply the different t values. Next video, I explain